I applied and then deferred a year. Sorry. If you're ready.
Okay, guys, so a couple things. Before I forget about it, I want to tell you about the modeling assignment. The modeling assignment, what it is essentially, you're going to be building molecules on ChemSketch. Yeah, have you done ChemSketch yet, Dr. Morgan's class?
Yeah.
Okay, perfect. So you're going to be building molecules in ChemSketch, and then you're going to be using Chem3D to minimize those structures. What that means is it'll start twisting angles, twisting dihedral angles, and looking for, okay, what's the lowest energy conformation? Is it staggered? Is it eclipsed? Is it staggered anti? Is it staggered gauche? Those types of things. Yeah, does all that stuff sound familiar? Yeah, from chapter 4. Okay, so that's what you're going to do. Ordinarily, what we do is we finish up the methyl eugenol today, and then we would, there's laptops that the college has, and we'd all open up the laptops and get started on it. Just get a start on it, like 10% of it, just so you get an idea of how it works and everything. Problem is, all the laptops this semester are being used constantly for students who are taking tests and responsives because they have a Chromebook or blah 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 blah. So you can't use the laptops. So what I decided I'll do, I mean, everybody ends up doing most of it on their own anyway. What I'll do is I will record a video of me getting it started, like I'm going to be doing it, so you know where all the buttons are and everything like that. Okay? We'll do it like that, and then I'll put that up. Okay?
Are we using specific software? So we're using ChemSketch and then we're using something else to minimize?
Well, it comes in the ChemSketch package.
Oh, okay.
Yeah.
Okay.
So if you downloaded the ACD labs, maybe on your own computer. Now, if you didn't download it on your computer and you're like, oh man, how am I going to do this assignment? That's why we did the VMware assignment, right? The VMware will get you on campus, digitally, and then you can use ChemSketch from on campus. Okay. Anything else to tell you about that?
How was your weekend?
My weekend was good. I bought my son an indoor basketball game like you have in the arcade, yeah, we did it for about 2 hours.
I thought you meant like one of those ones that you hang on the back of the door.
That's where we started a couple years ago. It's escalated. Yeah. Anyway. Yeah. Okay. So today will actually be. This should be knock on wood, a little bit shorter. But I can come up with stuff for you guys to do. I don't want you to go after tuition back. Okay. Just kidding. So anyway, what you're going to be doing is here's your guys' stuff. Looks like dilute coffee. You're going to weigh that, all right, and find out how much you got. Be sure, by the way, if you've got your empty weight with the tape, get your today's weight with the tape. Okay. I usually think it's better don't do it with tape. But whatever. However you did it last time, do it this time. And then you're going to do the math, okay, and figure out how much you got. If you have much more than 0.25 grams, 250 milligrams, come talk to me. There's a problem. You've created matter out of no matter. And if you end up with a negative number, you also, didn't evaporate glass. So come see me in either of those unusual situations. It doesn't happen that much, but if it did, come see me. We'll figure it out. What else was I going to tell you? Okay, but the chances of this being 100% methyl eugenol, right, the stuff that's going to attract the male fruit flies, is 0. It's not, okay? It's going to have some impurity. So you may do the math and you decide, I've got 100 milligrams, okay? But if it's only 70% pure, you don't have 100 milligrams, you have 70 milligrams in there, okay? So we're gonna come up with we're gonna use TLC to decide what the purity is, okay? once you know the purity, you're going to dissolve it so that you have roughly, well, not rough, well, I mean, rough because it's based on your subjective interpretation of your TLC. That's how you're deciding the purity. And I'll help you actually. You'll look at it under UV, you'll take a picture with your phone, and then you can come up and we can talk about it together, distanced. And then once you know how much, what your purity is and roughly how much you have in your little dish, then you're going to make a solution of it. And the solution, you're going to add enough methanol so that it is 60 milligrams of pure methyl eugenol per milliliter of methanol. Okay? You're also going to have a partner. And do we actually have 8? Oh, look at us. That's great. You don't have stuff, so yeah, but that's no problem. We'll just get you to partner up with somebody. And then, so you're going to partner up, and then together, you're each going to make, okay, I'm going to take my stuff, and I'm going to make it 60 milligrams per mil, because I know what the purity is of mine. And then I'm partner number 2. I'm going to make it 60 milligrams per mil, because I know the purity of mine. And then once we've decided that, and after I've checked your math, I like to check that math, just to make sure. Because then you're going to combine your products and stuff. And once you combine, you ain't uncombining. Okay, and then with your combined solution, which is still, because this was 60 milligrams per mil, this was 60 milligrams per mil, you combine them, they're still 60 milligrams per mil, then you're going to set up 3 traps at a dosage that I assign you. Okay, and then we'll leave it. I'll hang them probably tomorrow morning. I'll hang them out there, and we'll catch flies for a week, and then you will. So you and your partner will have your 3 traps, and then down the road we'll assign you to a comparison group, and that comparison group will be a different dosage, right? So if you were 5 milligram dose, you might be comparing to a 0.5 milligram dose. Okay? And you will use statistics. You use something called a student t-test, and there's a really good video. This guy's a really good explainer guy. That's part of the worksheet. And you can go and watch that a couple of times. It's 10 minutes, and he explains student t-test great. And so then you're going to use a student t-test to decide, okay, we have an average here, right? Let's say, our average is, we caught an average of 20 flies at 0.5 milligrams, okay? But here, let me do this on the section. I forgot, I wanted to talk about this, so this is a little off the cuff. Shoot. All right, so let's say we are 5 milligrams, okay? And we caught 6, sometimes it can really vary. We caught 6, and we caught 13, and we caught 75, okay? Hopefully it won't vary that much, but it can. Okay. And then, so I don't know what that average comes out to be. So that's going to be 88, that's going to be 9.4, right? That's going to be about 32. Okay. Isn't that?
That's, yeah.
Right? Okay.
Yeah.
Okay.
0.23, but whatever.
Oh, okay. Just super rough. So next we want to compare it to 0.500 milligram. Okay. And these folks had 8, and they had 18, and they had 20. Okay. All right, so what does that mean in here? That's 12 on the note, right? 37. No. Okay. That's 46 divided by 3, which is... What's that? No, that's 38.
15.
46 divided by 3. 46 divided by 3 is 15. It's about 15. It's a little bit more than 15. That's perfect for what we're doing. Okay, so now you need to be asked, can you verify that there's a dose dependence? That the more stuff you use, the more flies you get. Okay. Now, you might be tempted to say, yeah, average is 32, average is 15. Done. Okay. But is that like a, I'll put it this way, is that a safe average? Not really, because this one kind of threw it all out of whack. My favorite example is if you take Dr. Horgan's, let's come up with average salary. Come up with Dr. Horgan's, and mine, and Bill Gates. Okay? We're going to have an average salary of about $250 million a year. Okay? Is that really reflective of that group of people? No. It's not. You saw the car I just came up in, right? Okay, so in any case, so a student t-test says, well, I see that there's a conclusion that I can jump to, that yeah, you use more software and catch more fly, but is that a safe conclusion to jump to? All right. So it's going to, yeah, my guess is, I'm not sure, but my guess is it's not. But it will give you, it will take into account how much variance you have. And here there's a lot of variance. Here there isn't that much variance. Okay. We'll take into account how much variance there is and how big the difference is between the average, and then to a certain specified confidence level. I think what we say in the worksheet is 5%, or 95%, I should say. Can you reject the null hypothesis? And it's always, the null hypothesis, the dude explained it really well, but the null hypothesis is so weird. The null hypothesis says there's no difference. And so if you reject the null hypothesis, it's almost like a double negative. If you reject the null hypothesis, then you have indeed shown that there's a real difference between these two groups that you can count on. All right, does that make sense? Listen to the count.
What software are we using to run the t-test? Or is it like...
You can actually do it pretty easily by hand.
Okay, got it.
Or you can do it in Excel.
Okay.
All right. And there's a couple different ways you can do it. And I can't remember.
Can we use RStudio?
Can you use what?
Sorry. Can we use RStudio to run the t-test?
Oh, I'm sure we could.
Oh, you're really nice.
Yeah.
Then you just put it in.
You have to download a program for it, but you can.
Yeah.
You just
I'm sure there'll be more instructions.
But yeah. I like you to have a little bit of an idea of what's going on. So rather than just here's the averages, are they different? If you have some fancy statistical software, I want you to have an appreciation of how it's going about this. Okay. All right. And you'll compare it versus, you'll have an assigned group, like a comparison group, like I said. I distributed on a big spreadsheet that says, what your group is and who you're comparing to. Okay. And then, what the heck was I going to say? And then you will also compare it to just Eugenol. I'll set up some traps at all those doses for just Eugenol. Okay, you want to see. We also want to see, did the whole process make a difference in converting it from Eugenol into methyl Eugenol? And then we should also see. Wait a second. We're going to dissolve this in methanol. We're going to put methanol in those traps. Okay. So we should see, does methanol attract them? Okay. So these are our controls, right? Okay. So, let's talk about what we're going to do today in terms of figuring out how much you got in security and how you set up your traps. Right. So, weight, product, crude, and determine percent purity. Okay. Okay. So the first thing is weigh the material. empty flask. Okay. And you know, that little star means if it ends up being greater than 250 milligrams, 0.25 grams, or if it's negative, come see me. We'll talk about it. Okay, so say we have 0.150 grams, okay, which is 150 milligrams. Okay. But TLC indicates purity of methyl eugenol, okay, we'll abbreviate ME, is 60%. Okay. Then really, have 0.60 times 150 milligrams equals 90 milligrams. Okay? Does that make sense? Yeah? Right? You have 150 milligrams of the oil in there, but some of it's maybe unreacted starting material. Some of it's other junk. Okay? A lot of the time we'll see a streak down at the bottom of our TLC plate. All right? And so we've decided that it's only 60% pure, and so it's inside this flask. Let's say this is the one. It's only 90 milligrams of methyl eugenol and stuff. Okay? And that's what we're going to base our calculations on. All right? Okay, so, but how do we decide purity by TLC? And it's going to be a judgment call, okay? It's going to be, you know, subjective for sure. All right. A lot like the one you did for aspirin. Material, there's our reaction. We do have our desired, which is methyl eugenol, a pure sample, likely. There's another lane of reaction. And here's our code. Okay, all right, so let's say, let's remind ourselves real quickly of the structures, right? Converted that's eugenol, starting material. Okay. So, now your advanced TLC folks, I'll put the tough questions here. Would we expect the product to be higher on the TLC plate or lower on the TLC plate? Thoughts? How do we make that decision?
Polarity.
What's it based on? It's based on polarity. So you got to decide which one's more polar. Which one is more polar, top or bottom?
What are we using for this?
Hey guys. I'm so sorry. Sorry.
What are we using as our solvent?
Well, let's just answer that question. Right now. So which top is more polar? Good, good, good. Yeah, because it still has an OH. Remember, and that's one of the kings of polarity because it can do hydrogen bonding with TLC. So this is lower, less polar. So So now we need to think back and remember, okay, what's the trend with TLC? Does more polar stay lower, or does more polar go higher?
Polar travels faster, higher.
Which travels faster?
The polar one?
No. Reverse. Yeah. I mean, more polar, more better, more faster. Yeah, it seems intuitive that way. But think of this as stickiness, and it's stickiness based on polarity. So the more sticky your product is, the more polar, then the harder it's going to have a time progressing up the plate. So the more polar stays lower, the less polar moves higher in general. Great. Okay. What's my picture that I created? Here's our desire. That's here. All right. Do we have evidence from this TLC? Do we have evidence that we made product? That suggests we made product.
Yes.
I'll tell you right now, we have no proof. Okay, you're not going to get proof on TLC. Okay, the only thing TLC can ever prove is that two things are different. Okay, so but we do, because we had the desired, it went right there. And we have a spot in our reaction group that lines up nicely with our desire. Okay. In our, so if you just look at like, this is what I want you to remember. Well, let me, okay, sorry. Down. Which one do you think you have more of? Product or starting material? This unreacted starting material or desired product, assuming that that is the desired product? Based on size of my dots.
More of the reactant.
What's that?
More of the reactant, the starting material.
More of the starting material. Because that's so big? Yeah, awesome. You fell into the trap. I wanted you to fall into the trap. This has nothing to do with your reaction crude. This is a bottle that we had on the shelf upstairs that we put in there. Yeah? And students do that all the time. That's why I made that spot so big. Okay? The only thing, we sometimes call these lanes. Alright? The only thing that tells you about your reaction crude is what's in the lane. These just help you identify your lane, or the stuff in your lane. Yeah? Okay, so now, remembering that only this tells us about our stuff. What's bigger, starting material or product? Product? Yeah. See how that dot is bigger than that dot? Okay. Why do these look different? Why is this ginormous compared to that?
Because we put more stuff on.
Because I spotted the 3 times there. Yeah, exactly. Okay. All right, so what you have to do is you have to look at these spots and make some kind of guesstimate. What do I need something in here. I wrote something down. Okay. Yeah. So let's say percent purity of methyl eugenol in your reaction crude is your judgment. Okay. based on size of spots. Okay. So I'll show you what I would do. Like I would say, okay, you know what? In terms of size of spots, this is what I was trying to draw, but maybe it doesn't make sense. But I was trying to draw it like, I would say 80-20. You know what I mean? Does that seem right to you guys? I mean, if they were like that, that's 50-50, right? I was trying to draw it so, you know, this is about 4 times bigger than that, 80-20. Does that make sense? Okay. So that would lead you, if that's all you had to think about, then you'd say it's 80% pure. Okay, but a lot of the time we get a streak here. You guys got to use brand new Eugenol. Congratulations. I'm hoping that maybe you don't have a big streak here, but in the past we normally have a big streak here. Side products, we don't know what they are. Made some other junk. You cooked it pretty good, 135 degrees or whatever for an hour to 2 hours. Okay. So we have to sort of take that into account. So we're on uneven ground here on our estimate. This is a real rough estimate. But all right, so if it was just that, I would say it's 80-20. But this has costed me some of that purity as well. So that's where I came up with 60%. Does that make sense? And I have students sometimes, and I don't want you to be upset with yourself, where here's the product, here's unreacted starting material. You might come up, I think this is only 10% of the Eugenol. I don't care. It's all good. It's gonna be okay. But all right. Okay, so does that make sense? How we decide the purity. And like I said, take a picture under the UV lamp and everything like that, and then probably good. Why don't you bring up the picture and we'll take a look at it together, and I'll let you make the estimate, but I'll hear your reasoning. Does that sound good? Oh, great. All right. From there, you're going to do 2 calculations so that you can set up your track. I want to make sure that you're comfortable doing that concentration. Okay. Did anybody need the thing printed out? It was the same one that we had last week, so hopefully you all have it. If you don't like it, you can tell more. When you're making your traps, there's a big hole and a small hole, okay? I mean, not a huge difference between the two. But put the string through the smaller one, and then you make a knot, because that's how it's gonna hang. And then the flies go in the bigger hole to perish. Okay. Okay, so, and then you're going to put in a squirt of glycerol in there, 1.5 mils is what we want to do. So about 1 squirt of this kind. Okay. All right. So I'm going to do 2 calculations. Here's the first one. Methanol, that's the abbreviation for methanol. Methanol calc 1. Say you decide you have 90 milligrams methyl eugenol in your flask. Okay? In here. I got 90 milligrams right there. Right? Need enough
concentration